Good afternoon and welcome to Think Purple Math. The topic on this lesson is solving radical equations. A radical equation is an equation that has a square root or a cube root function inside the equation. So if you look at the screen there's some bullet points, there's some reminders to kind of get us started there. This is kind of how we're going to do these. The first thing we're going to do is we're going to isolate the radical. That means get the square root either on the left or the right side of the equal sign by itself. Similar to combining like terms and getting the variables on one side. We're going to square both sides. That means we're going to go ahead and raise each side to the second power or cube power. In this case, we're only going to do the square root function, not a cube root, but we'll do those later on. You'll see that on Think Purple Math as the year goes on. We're going to apply inverse operations, and then we're going to simplify. So we're going to look at about 6 problems here, and each problem may or may not become more challenging. It could be. Here's the first question, question 1Q, and that's followed up by answer 1A as we flip the page. The square root of x minus 4 is equal to 3. The square root has been isolated already. The square root, or the radical, sometimes you can use that word as well. The radical is on the left by itself. So we're going to go ahead and square both sides. We're going to raise everything to the second power. If you square a square root, you're going to get what's inside out. 3 squared is 9, so it starts out fairly simple. X minus 4 is equal to 9. Apply basic inverse operations by adding 4. X is equal to 13. What I'm going to do with the first problem, and only the first problem, is I'm going to go ahead and check it by plugging back in or substituting our answer back in the equation to see if it makes sense. So we're going to put 13 back in the square root in place of x and make sure that it checks. So we have the square root of 13 minus 4 is equal to 3. If we apply the order of operations, 13 minus 4 is 9, and the square root of 9 is in fact 3. So that does check. The answer does make sense. So the answer is 13. Problem number 2. Similar problem. Now the square root is on the right. Process really doesn't change. Is the square root or the radical isolated? In fact, it is. So we can now go to step 2, which is to square it. 5 to the second power is 25. If you square a square root, you get what's inside. It undoes, it's an inverse of the square root. Subtract 3 on both sides. 25 minus 3, 22. But I'm going to put my variable on the left. I always put my variable on the left. 22, final answer. Okay, now we're going to go to a little more challenging problem. Now we have to actually isolate the variable. In this case, we have the radical, which is below my arrow, and we have a negative 8 that's connected to it. So we're going to apply inverse operations and unhook or cancel out the negative 8 by adding 8 to both sides. Now our square root has been isolated, and negative 3 plus 8, positive 5, using the addition rule. Adding 2 numbers that are different sides, subtract and take the sign of the larger number. Now we can square both sides. 5x minus 5 is equal to 25. And now when we're at this level here, we are at a 2-step equation. We're going to apply inverse operations. And hopefully we don't come up with a fraction. In this case, 5x is equal to 30. Divide by 5. X is equal to positive 6. Final answer. You can always pause the video. What I recommend you do is to write the problem down, pause the video, make an attempt to solve it on your own, and then see the rest of the video. Positive 6. Whoops. All right, we go to problem number 4. Now we have a square root that's being multiplied by a factor of 10. The opposite or the inverse of multiply by 10 is divide by 10. So we're going to actually divide 10 to get the 10 off of this square root. What we do to one side, we must do to the other. We have the square root of 9x is equal to 6 here. 60 divided by 10 is 6. Now you can square both sides. Or we can square both sides, you and me. 9x is equal to positive 36. Divide by 9 both sides. And x is equal to a positive 4. Final answer. Give you a moment to absorb that drawing or that. These can be uploaded, these problems, to Google Classroom, which I use as well for students that want to actually see the hard copy of this, not just a video. Now we have problem 5. We have square roots on both sides. And the first time students see this type of problem, they're kind of not sure how to approach it. But it's actually one of the easier versions. Here we can go ahead and square both sides right now. If you square both, anything you square comes out. So 3a is equal to 4a minus 1. Now we have a two-step equation, but we're going to have to work with some negatives here for a moment, just temporarily. Subtract 4a on both sides. Bring down my equals. 3a minus 4a, or 3a plus negative 4a if you prefer, is 1 negative a. And that's going to equal negative 1. So my students, after a while, will be able to handle this part very easily. If we know that negative a is negative 1, then we'll know that positive a is positive 1. We simply flip it. And for those of you that are new or have not seen this, I'm going to rewrite this here that's in the circle. That's a negative 1a is equal to negative 1. So there's an implied negative 1 there. And then we divide by negative 1. And a negative divided by negative cancel each other out. A negative divided by a negative is a positive. And that's how come we get a positive 1 final answer. So anytime you solve any algebraic equation for the negative variable, you simply flip the sign and you have the correct answer. Positive 1. Our last equation is the same type of problem now. We have radicals on both sides. Simply square both sides. And anything being squared that's in a square root comes out. 3a plus 12 is equal to a plus 8. And the way I would work it here, I'm going to subtract the smallest a, or the smallest variable, as long as they're both positive now. Well, I get a 2a plus 12 is equal to 8. We're going to subtract 12 on both sides. I'm going to get a 2a is equal to a negative 4. And our final step would be to divide by positive 2. And we get a is equal to negative 2. And that, my friends, is your final answer. I'll give you a moment to look at that a minute before I move on. I squared both sides and everything else was inverse operations. We're looking for a -2, and there we are, final answer. All right, in closing, don't hesitate to visit Think Purple Math, and you can get some help with some math that you need help with. Look it up by topic. It'll be listed there. And have a great day, and always think